Okay, it's
Finally
recording?
in VR.
Yes.
Okie dokie. Good morning, GPC. Thank you for joining us in this evening. We hope you'll stick around because we'll be talking about VR games if you were not here for the few minutes prior. We'll also be giving some tips and tricks on how you can use Unity to develop. So, starting things off, when you create a Unity project, so I'm just going to pop open Unity Hub. When you do create, I didn't know this the first time, and you technically don't need to do this, but there's a VR option. So you can say you save yourself a little bit of trouble by doing that instead of needing to add a bunch of additional. I mean, you still have to add some stuff, but you don't have to add as much stuff if you click the VR option, which I didn't know was a thing. But it's already open. Fantastic. So this would be what your new project looks like whenever you do this, when you do the VR option. So you just have a directional light in your scene, you have an XR rig, and you have a plane. So this happened to me. So the first time I tried doing this just to see if the XR rig would work, I found out, I'm using an Oculus Quest 2, and welcome to everyone who's joining us right now. I had an Oculus Quest 2, and it was kind of freaking out, and I couldn't figure out quite why. Well, it's actually because you need to go into the settings here, and you need to allow unknown sources to be able to run games just straight out of Unity. And once this is ticked, it's not smooth sailing yet, but at least now Oculus is not the choke point anymore. So that solves that. Now on to the next section is there's a few different approaches you can do. The one I chose to do is using Unity's XR toolkit, which is it's more drag and drop, so you don't have to write as much code because they already gave you a bunch of it, which is great for when you're making your first VR game, or concept in my case. So if you don't know how to do that, then you just go to the package manager right here. So you go Window, Package Manager. You'd go down to this gear here on the right-hand side. You'd go Advanced Project Settings, and you need to enable the pre-release packages. Once that's ticked, you can scroll literally all the way to the bottom, if I can scroll, and then you'll see there's the XR Interaction Toolkit. That's what I used to develop that other demo. So inside the XR Interaction Toolkit, you'll have a bunch of super simple, well, not super simple, but you'll have a bunch of things that will help make developing more streamlined, such as an interaction manager. See, one of the funny things I did is I got my XR rig working, and then I would run it, and then I'd be able to look around, and then I thought, wow, this would be a bright idea. Why don't I try to move an object with a rigid body with my hands, and then I didn't have hands. And I'm like, okay. And that's because there was literally no code written for it, and I don't know what I was thinking, but I was probably just extremely tired. But if you have the XR toolkit, you just, inside your scene, you add an XR interaction manager, and you add some more things to your rig. So you'd add an input action manager, you'd add a locomotion if you wanted to be able to move around, and then a continuous move provider. And this just allows your XR rig to do something. So, for example, I can move around and I can grab things now, but I can't just grab anything. If you want something to be grabbable, you would just create an object, and then you'd attach the XR grab interactable, which is, and then after that you would attach the interaction manager here through the script over. It's surprisingly easy that I'm explaining it to you this concisely, but it was a nightmare to figure this stuff out, so I'm really glad it's working, and I can quickly demonstrate. This will be able to hear me though, but let's see. I'm gonna try anyway. Let's see. Anything going on in the chat? I've been suffering inverse chromatic for so long. I have tracked pose 3. Okay. Okay, so I took my headphones off, so I can't hear anything now, because I'm going into the Matrix. unlock my quest. Now if we do, there's my mouse. If we do play, should work. I know I might be getting quieter because I'm moving away from my mic. Anything? Cool. Isn't technology great? The quest is freaking out. I think it crashed.
Yeah, the greatest part about using Oculus Link is it doesn't always work because Oculus never seems to want to actually be set up properly. Just like what was happening here. Yeah, you might not notice, but if you're using a laptop, you will run into even more issues because of the fact that you have an internal GPU.
Okay.
So
Enable.
that's another issue I will bring up once it's my turn.
Okay. Now I'm in Steam Home for some reason. What happens if I do play? Okay. So we can see what I'm doing now. So after all that, you should be able to add like interactable items like this to your game, where you can just have like you can interact with it and you can warp with it after everything's set up. I'd say use the toolkit for simplicity, but and then you could also move around using the left stick here. So I've got my left stick bound to moving, and you can see I'm moving around this platform, and then you can throw stuff, and yeah. So that's that. Okay, so yeah, that's that summarized concisely. Basically, thanks to Unity, developing for VR is like simple, but not necessarily easy. But GPC is there. Yeah, so Jonathan, you ready to go?
All right, yeah. I guess I'll start talking about my experiences. So what Leo did was he used, well, as you saw, a plugin or package, I guess. Now that makes things easy. Me, I saw him struggle with it since we were roommates, and I'm like, I don't want to go through that. Let's try doing things manually. And I ran into a bunch of other issues. First off, I need to remember that I accidentally created a third-person VR thing, so let me just turn that off so that no one gets confused by that. Good is recording my mic. So this is another thing that I made for a jam, and I wrote the scripts myself because I wanted to try the experience. So one thing that I noticed was, hey, movement is hard. How hard would it be to create your own movement? What Leo showed was linear movement, which most of the time that works, but as you might have heard from the fact that VR is VR, some people get motion sickness. So I thought, hey, how hard would it be to create my own teleport system? I was able to in the end, through the help of just looking up things on the internet, because the internet is your friend. One important thing to know is particles in Unity are a lot more powerful than you might be thinking. Because this arc right here is done through particles, and the position checking is done through particles. Because a little known fact, apparently to me, I don't know how much other people know, particles can send collision data to scripts. So you're going to be able to, you can do stuff like your gun shoots particles, and then the particles hit something. That's now collision detection. Now that's really cool because it allows you to do, as you saw, arc-based movement. And this is the entire script for getting the hit position. It took in a particle system, and then on particle collision, it gets the collision data, checks if it's actually a ground and not a wall, then adds that to the hit position. And I have this so that I can have the fade out so that you don't teleport when you're facing a wall. Now, I was able to find the on particle collision thing easy. But one thing you don't find as easily as is with all things is that if I go to my controller and show the beam, you actually have to do one extra step. Hidden inside the collision, there is a little checkbox right here. You can see that's kind of in the mess of the particle system interface in the editor. Send collision messages. If you don't have that ticked off, this code doesn't work. I spent like 2 hours looking up how to fix this, and all I had to do was turn on that checkbox. The message here is that, hey, it's you really gotta snoop around everywhere you can. So that's if you want to do your own particle system and you want to use arcs. Hey, particles or a teleport system, particles actually work. Now, as you saw, I also am using the XR rig because I did start with the VR project rather than the 3D like Leo did. But one thing that I did was, again, do everything manually. So you have your player input, and this is how I handled everything. I used a new input system because I want to get more experience. It did cause me a lot of other issues. But one thing I will bring up for that is more problems that I found as I was researching movement for VR. This is actually where my third person will actually be helpful, so I'm actually going to turn this on. As much as this is cursed, I will be playing it in third person, so be prepared for that. So, alright. This is third person VR. You don't want to experience it, but you can see I have a cylinder, and that's a rigid body. If I actually go against a wall, you can see I go right against the wall and not teleport into it. How did I do that? Well, I actually had to set up a system so that when you move your head around in the real world, you can see that the rigid body is actually moving a little bit. I really got to be careful I don't roll on my cable. So that is one thing that I always forget that some VR games fail to consider. You might have experienced it in some things. Like, I know from my experience with VR chat, when I walked away from my starting pose and like into a wall, I just walked into the wall and suddenly I was flying and I could see my avatar in the real world. And it was like, oh, I forgot how much of a pain this was. So a lot of games have different ways about it. Some games, they just, if the head is colliding with an object, they just make your screen go black and just say, please don't put your head in objects. Others just don't do anything. But the real ones, the real cool ones, are the ones that actually translate your head movement into world space movement, which I had to try for myself because I found it interesting. So how did I do that? Well, of course, I wrote my own script, as with all things. I called it camera correction, and I will share it with all of you. This is the entire script. Yes, it actually wasn't too hard when you think about it. When you look at one thing when you want to develop your own system is just use the fact that when you're running Unity, if I click play, you can still look at all the hierarchy. You can still see like, oh, left-hand controller, what is the data of position and rotation and all that, and you can see like if I grab my headset and turn it on, you'll see that the local position matches, and that's because that's where the tracked pose driver is. And I'm like, oh, I can actually extract the data of the VR systems because unlike regular gameplay, VR is in world space, like a 3D mouse. When you're interacting with objects, you're not just shooting a ray from the center of the camera, you actually have to pay attention to where the hands are in world space. Same for the body, which, of course, that is stored inside of the main camera. So how did I actually get it to do that? Well, I had it an offset parent that just does the inverse of the camera. So you can see here, it does just that. The offset transform took the, position and just inverted it. And I also canceled out the Y because I didn't want to remove the up and down movement because that is something you can do yourself. Now, You may be thinking there is another way to do this. Just don't allow the player to move their head, which is where you go in main camera and then right here, rotation only. That works. But for me, personally, I don't like it when I move my head in the real world and I don't move my head in the VR world. It doesn't feel right. It makes me a little nauseous sometimes. I tried that when I was trying a seated version of a game. So there's a lot of, from there you can kind of understand there's a lot of different things that you start forgetting as a programmer because you have to make the actual systems that function. You're going to end up writing a lot of this kind of things if you want to accommodate everyone, like teleport versus linear locomotion, snap turning versus smooth turning, and all that. But yeah, so I will mention again, camera correction takes in the camera, adds in the inverse of the offset to this, and then I actually have to do one more thing, add the change of position, which is what this is, multiplied by the rigid body's rotation to the rigid body's transform. Because if you didn't notice, everything is surrounded by XR rig, which I decided was the rigid body. This is related to what Constantine mentioned of a tracked pose driver. Here's another thing you got to think of now. Hey, you're forgetting that there's this cool thing known as the head movement, and that is something to consider. So yeah, that's why I want to bring that up now. The teleport pad, again, I use the particles, and it just does that. So I won't be talking too much about that. So I'll talk a little bit more about my experiences with the VR dev because I think it's a good lesson to consider, and hopefully it'll shine some light on some problems you might encounter outside of just the basic differences of I had to code a lot of things. One thing you may have noticed is in VR you have two hands. A lot of games, the fact that you only have one mouse and not two make it obvious that you're only going to be aiming with one hand and it's going to be really direct. But when you have two hands, you have a lot of things to consider. One of the examples of the things, I should really just turn off the VR or the third person. Jesus, don't do third person VR. It gives a massive headache. There you go. Now I can actually talk about what I'm doing. Okay, so you might have noticed I use my left hand to teleport because I'm a right-handed person, but you might want to have the ability to teleport with the opposite hand, and that was something I had to set up. What does that mean? Well, you're going to have a script that can take into account the fact that you have more than one hand. Like I can snap turn with one hand, I can snap turn with the other. How did I go about that? Well, it also depended on how I did the teleport system, which I have a lot of redundant scripts I will mention. So I have a script called toggle beam, and that's just how I toggled the beam. But you can see right here, I have something called opposite hand, where the hand takes in a reference to its own class, and it's called opposite hand. How I did it was whenever you flick the joystick to do the teleport, it checks the opposite hand and then says, hey, are you on? If you're on, turn it off. And that's how I did that. And that's something you might have to think about when you're actually handling this hand system. This might be relevant for, well, some interactables, I believe, because you might not want both hands to work with it. Though, that might not always be the case. One example is grabbing. In VR, as you saw with the XR Interaction Toolkit, when you grab something, there's different ways to go about it. One way is to do what they did, and it's kind of just parent the object to the hand and then reset the transform, is what I believe it's doing. Because you saw that it just replaces the hand with the actual object. If I do a thing here, which just, there you go. I set it up so it just parents it to the hand in the world. Because in Unity, there's this nice function called setParent. And it's simple enough that you can just set parent an object, and then that'll allow you to hold things. Now, of course, that doesn't come with its own issues. One example is, so you can grab things, right? But what if you have, if I can create another thing. Come on. Did it break? Don't tell me it broke. Okay, I'm just gonna do it manually and grab the cube. Where's the cube? I see my mom close my door. There you go. Now there's more cubes. So one example is, what if the hand's hovering over two objects? Well, with my system, you can do that. And that depends on your actual needs. This might not be great, because for example, if you're holding a gun and then the gun is kind of like at a weird angle, that's not going to be fun, and that's when you're going to have to start considering, limiting the abilities of the player. And that's a lot of considerations that I want people to think about when they're making VR, because going in blind with like, oh, I know how VR games work, and then you remember how many different systems exist within VR games, you're going to have a bad time when you start realizing, oh, I got to do this. Oh, I got to be able to grab from the other hand. And if I'm using a weird list system, like I am because of the fact that you can hold two things, I'm going to get a bunch of errors, and it's going to break the game because I didn't pay attention to that, and I'm going to have to bug fix it. So a lot of things like that is things you might want to consider. So that's basic VR games. But you might have noticed I have this nice thing. One thing you might encounter as you're making a VR game is, man, pose stuff is cool. Like, I want to be able to track a motion, I mean. Like, for example, if you want to track a punch, like this motion, or you want to track a S, an S, or like writing in general, you can do that. Or even, hey, you know that fun thing everyone loves, a pen? You can kind of see where I'm going with this. So this is a system I had to think about how I would do, because, well, I wanted to do a circle test where you can draw a circle, and if it's a perfect circle where the spacing between the dots is the same, or within a degree of variation, it spawns an orb that can do stuff like spawn a cube or destroy cubes. That system is something that a lot of people find interesting because, well, it's about tracked pose driving. Now, of course, it looked daunting to me at first, as with many things in VR, because you're like, oh, it's not too hard at first, then you see all the issues, and you're like, oh, that's hard. For me, how I went around that was I thought about how do I actually track, well, emotion. You might have seen this in like other systems and like replays where they actually just kind of store the key steps. So I'm like, oh, I can try that, and that's what I did. So I created a class called Phantom Mesh, and what it does is it uses a queue, because I like the idea of using a queue, and just kind of on a fixed update and delay, so update skip count, so that's how many fixed delta times do I use between each spawn. That's why you saw a consistent timing between spawning. Now, of course, this was before I remembered coroutines existed, because coroutines would allow you to do this, but with a little more fidelity, because you can actually set the wait time as an exact number, rather than fixed delta time, and then how many frames do I skip. And also, it's probably more efficient than updating a counter every time. But this is what I came up with at the time, which was probably midnight, which is not a good thing, because it ended up scrapping so much code that was not good. No crunch, please. But that is something that you might want to consider. So if you want to actually track it, you can see here I have update position, and what it does, it uses a queue system. You dequeue and inqueue an object so that's always looping, and then you can teleport it. I have a lot of weird code here that was needed this was to despawn it, but for example, if you're just tracking the pose and you don't need to render the orbs like I did, you might do something like a low fixed update count, and then you just have transforms rather than game objects, and then you just don't render anything. You just always track it. Now, if you want to actually track a shape, that was a little harder for me to figure out, and I didn't get it perfect. But what I did was, because I was doing a circle, there's a few things you can think of. So one thing is a circle, you want a consistent radius. So what I did was I found the average position, which I stored in npos, and I just checked the distance between the dot and the center, and then I stored the variation, so max and min. That way I can see, hey, is the radius of the circle mostly consistent? Because here's a fact about VR, man, do positions love moving. my controllers, when I left them on the table, they would still change position, even if my headset was off. Mainly because just slight vibrations are tracked, which is awesome for accuracy reasons, but not awesome because you're like, oh, I don't like having to use ranges and numbers. But yeah, so you're going to have to take that, remember that, hey, there's going to be some variance. And for me, because I wanted you to be able to do circles of any sizes, I said, hey, let's actually use that. The variation will become what I actually track and use to know if it's a valid circle or not. Another thing I wanted was that the circles had consistent spacing between dots, and that's what you can track here by just going through each dot and then just going the distance between the current dot and the next one, if you've ever done this type of system. And then you just got to make sure everything's true. So this is something I came up with for tracking motion. If you want to have more complex shapes, you might have to think about how you materialize them. You might be thinking you can just take a pre-existing one and then just track it, and I thought that too, but then I remembered VR is not always in the same rotation. If I actually go back in VR, I will show this little fun fact, but you need to be able to do circles both facing this direction while also facing this direction and maybe even like on top of them, because you can move your head freely. Inside of VR games, you're in a lot less control, so you need to work around the control that the player has, both in the ability to move their head however they want, move their hands however they want, and also do stuff like aim the mouse where they're not facing. Obviously, some cases you might want to get rid of that, or in my case, I forgot about it, so I just left it in. So you can just shoot backwards and it'll still work. But you might not want that because you don't want them to be able to teleport into something they can't see and to complain, hey, why did I die there? I couldn't see that. Well, that was because they were moving somewhere they couldn't see. It's a little bit reaching design at that point, but here's the thing. As programmers, we need to program the design what the designers want, or if you're your own designer, what you want. So that's me talking about just VR itself, because I found that VR development was a lot more interesting. I did actually have some gameplay aspects, like the actual game that I didn't show, which I don't think I need to, because we're here to talk about VR, not just general game development. I will agree with what Leo did mention, that at some point when you're making a VR game, you might just end up making a regular game, and then you realize, wait, this might not work as well as I think it will in VR. So yeah, hopefully this was informative, and maybe you'll be able to work on your own VR projects a little easier now that you have seen some of our pitfalls and troubles we ran into, and also how we solved them, both me and Leo. Leo using a package which helped him work on it decently fast, and then me doing things manually. I spent so many hours on this, and I regret it because it ruined my sleep schedule. Well, I regret it a little. I still found it fun, because honestly, I was hesitant about VR personally, because I thought VR is a gimmick, but having tried it myself, the freedom as a player it has is great, and the new things I can try doing in as a programmer were also cool. The main mechanic of my game was I'll show it now, since it's something that I can't do as easily if it wasn't for VR. But if I spawn two squares, the mechanic I coded was the ability to weld squares together. And what's interesting is in VR, you can do stuff like move your hands left and right easily. You don't have to do weird things like welding it and then using the scroll wheel to stretch it out. And you can also do stuff like rotate it, which means if I grab this one, I can do stuff like connect it like this, or like this, or even like this, or bye-bye. Oh. Or even like this. Oop. Yeah, like this. And that was really interesting to me, because that's kind of what VR allows you to do. I almost rolled on my cable. That's scary. Hopefully this was informative and maybe even fun, and now you actually are motivated to make a VR game. Because honestly, having seen it, I kind of want to see more people make small, simple VR games because they're actually not as hard as you might think if you can get past the original pitfalls as me and Leo have done for our Jam games. Yeah. I'm going to stop recording now, so we can just do our GPC after hours.